compare the tensile strength, elongation,
Okay.
hardness from
Okay.
alloy steel versus ADI.
What I'll do is, this is the heart of ADI, the microstructure. You're getting 90%
Comparing it
steel.
to alloy steel, right?
Yes, exactly.
So, like, compare the cost for me. Just to round up, where is the largest market for ADI right? Do you find the relevancy of cast iron going down due to aluminium and things like that? Like adding ADI to a portfolio, is a little bit of a like insurance policy, I would say.
I actually got a lot of customers.
Correct.
Because they searched me from ADI.
So Preet, you've come all this way to talk to us about ADI. So what is so important about ADI? What exactly is ADI? I mean, let the audience know. Let's just start right away.
Sure. ADI, Austempered Ductile Iron, is basically a ductile iron which goes through a special heat treatment process, and we come with the material which has high toughness, high strength, which maintains its elongation, and often comes at a lower cost than high alloyed steels.
So it's a form of iron, of ductile iron, basically.
Yes, exactly.
Austempered ductile iron is what you are talking about.
Yes.
Okay, great.
It is ductile iron.
So that's it. Must be something that's really new technology. If you really want to base an entire episode about it, so that's really nice. So we're going to learn about ADI a little more today,
yes,
right, in detail, and we're also going to compare it with alloy steel.
Yes, certainly,
right?
certainly.
Great. So how did you first come across ADI? What were your first experiences with it?
That goes way long back. So I want to talk about why I came into Foundry first. So I'm a fourth generation Foundry man, by the way.
Fourth generation.
Yes, exactly.
Oh, that's it. Nice to have you. Fourth generation. That's good.
But I wanted to be a software engineer when I was a kid. I wanted to make games.
Okay.
Yeah. It was in probably 8th standard when in the class, our teacher asked us, have you seen a furnace? And I was like, almost every day.
Right.
So everybody was like, okay. So, well, after a few questions, it turned out to be a school trip at my factory.
Okay.
Yeah, it was probably in 8th or 9th. So my father hosted everything, and I was proud that day to host my class in the Foundry.
Right.
And eventually it came to my mind, yes, I can do this.
Right.
Yes, I can do my family
So
business.
what age was this?
8th standard, probably it was in 2000
Okay.
and
Got it. So when you were in school, basically.
in school, yeah,
Right.
yeah, in school.
Right.
Yes. So then I did my engineering. I did my mechanical engineering, changed from software engineering to mechanical engineering, and I came into business. So there was this phase in around 2016, when every young guy wants to do something on his own, and I was so curious to learn more about foundry, about metals, about metallurgy. So I came across ADI at that time.
This was when you joined your family business.
Yes,
around
this,
that time.
Exactly.
Okay.
2016.
Like fresh out of the gates of engineering, and you're trying to do something in the world.
I did something in between. I did my master's here from SP Jain in Mumbai.
Oh, so you were in Mumbai?
Yeah, exactly.
Okay.
That was a family managed business course.
Right.
So I came to my factory and I learned about ADI. That time I read it from somewhere. I was intrigued. This was something like I got to know, like vibranium of Wolverine.
Right.
I was thinking of that.
You discovered something like revolutionary, and you wanted to experiment.
Found kryptonite.
Right.
Okay, so I read more about it. I found a guy who was near to me. He had experience in Austempered process, and he's an IITian by the way. So I got a bucket tooth made in casting.
Bucket tooth?
Yeah,
Okay,
the bucket tooth for excavators.
Right.
Yeah, I purchased one of JCB from market, and I just got a pattern made. I got it casted, and I got.
So this is like reverse engineering.
You
How to get the pattern to make the pattern.
Yeah, you can call it reverse engineering because I purchased a product. I gave it to my pattern maker. He made a hand molding pattern that time for me. I remember it was hand molding. So later I got it Austempered, and I got it into my factory, and I was thinking, okay, let's test it. I got my fettling guys. They came with those big hammers, and they started hammering the product, and they were like, "Sir, ye to toot gaya."
It broke. Okay, so your ADI this was your first experiment with ADI.
Probably it's supposed to break as well with those hammers. I don't know, but I didn't know how to test it.
Right. Yeah. You must have some really strong guys in Punjab, man.
Well. But now it's totally a different story. I know that you make the test specimen to check the mechanical properties. It's a different process to check the properties of ADI as well, because I told about work hardenability.
Right. So what you're essentially mentioning, sorry to stop you, is that you can constantly go on, work hardening it until it achieves the desirable properties.
No, we don't work harden it. We make the product, we put it into application, and in the application, it gets work hardened.
Okay.
Like in ground engaging tools, that way.
And okay.
Yeah, and there are some the grades of ADI. So there are some lower grades, upper grades, grade 1 to 5 as per the ASTM standards. The lower grades, you can increase their wear resistance by short peening. Short peening is a process. So after you have casted your product, and the wear resistance is increased by short peening, and grade 4 or 5, which are more wear resistant grades of ADI, they have high work hardenability, and they give more wear resistance at similar hardness levels of steel. They tend to, there's a term called TRIP. It's called transformation induced plasticity.
Okay.
So their fatigue strength, their wear resistance, this increases as they are more into application.
Okay.
Yeah.
So yeah, I mean, now I understand from the term work hardening.
Yeah. Okay.
Okay. Got it. I mean, light bulb. Okay. So you have your first experiment with ADI, right? It fails terribly, right? And then I assume you go back to the drawing board. You're an engineer, right?
Yes.
You re-engineer it.
Yes, exactly.
Right. And what is the second attempt like?
What I did was,
what did you do wrong?
No, see, the first was it's not like you take a casting product, you then cast it in some ductile iron grade, and you give it to the heat treatment guy, okay, or temper it and give it back. It's not like this. It's a complete, there's a SOP has to be followed.
Okay.
Yeah, and we don't cast a standard ductile iron grade for this ADI. So there is a specific recipe to do it.
Okay.
You have to make it hardenable. So you allow it.
You prepare it for being hardened.
Exactly. So we we put the alloys in it, which gives hardenability to ductile iron, and then there are some microstructure changes as well. What we did between a difference between pyolitic and ferritic base grade of ductile iron I'm talking about. So once you get the right base grade for ductile iron, then there are two heat treatment processes. So you have to balance out the heat treatment routes of the first process and the second process to get the right product.
So are you going to tell us what these processes are?
Well, of course. That's why I'm here for.
He's here to share. That's good.
See, Ian, I want to add value wherever I can, without not compromising my,
secrets, trade secrets.
I didn't want to say that word.
Right. Trade secrets.
Yeah. Right. So okay. So
no, it's good. I mean, you've piqued the attention of the audience quite a bit. Like anybody who's making cast iron right now would be pretty much watching this, trying to understand what ADI is, right? As you were curious maybe back 8 years ago. So let's just move on to the applications. Or you said ADI is largely compared with alloy steel, right? It's a replacement for alloy steel. So when we talk about alloy steel versus ADI, right? I have a few points that I want to ask you.
Sure.
Right. So let's look at properties. Like compare the tensile strength, elongation, hardness from alloy steel versus ADI.
What I'll do is I'll tell you the grades of ADI first.
Got it.
So there's standard ASTM grades, grade 1, 2, 3, 4, 5.
Okay.
So
very simple.
Yeah, simple.
Right. 1, 2, 3,
no,
4,
I'll tell you more about those grades.
Right.
Like grade 1 is a 900 by 9 grade, which means it has to give 900 megapascals of tensile strength and 9% elongation.
Okay. So that's a 900 by 9.
900 by 9, exactly. Easy way to say it.
Right.
So the hardness levels are roughly about 300 BHN for this grade. And once you move from grade 1 to 2, 2 is 1050 megapascals of tensile strength, then grade 3, then grade 4 and grade 5, ultimately you are getting 1500 megapascals of tensile strength, but not in elongation over
How
there.
much of elongation? Just
1%.
1%.
The standard
so
is 1%.
1500 by 1.
1500 by 1, exactly. Exactly.
So this will be very hard.
It's very hard, exactly. That's what I was going to tell you about. The hardness is about 500 BHN.
Right, because we know elongation is inversely proportional to hardness.
You are very right about it. So you were talking about applications now. The first 1, 2, 3 grades, so wherever cost and weight is important, the designers are choosing grade 1, 2 and 3 over there.
Wherever cost and weight is important.
Weight is important.
Okay.
And where wear resistance is important, as we talked about work hardenability, wear resistance, fatigue strength. So their grade 4 and grade 5, they come into picture.
Okay.
Like I'm making short blast blades. So we used to purchase blades in high manganese steel.
Okay.
Purchasing for a long time, 35 years. And probably about 3 years ago, when we were doing good, we were making good ADI. So I made a pattern for this short blast blades, and I started testing it out in my foundry.
Okay.
The practical results were we were changing the blades after 15 days.
Oh, okay.
For the regular ones. And for the same time, initially, I think I got lesser life in the beginning, before that period, lesser life with my ADI grades. And once we fine-tuned everything, we were getting roughly 3-4 days more than the
alloy steel.
Yeah, exactly, alloy steel.
Right.
But important point is, they were about 50% lesser in cost.
Okay.
Yes.
So you extensively basically double the efficiency almost.
Yeah, if you did the maths in your mind, yeah.
Right. So also it's important to understand. You said something very important. Like not only did you make ADI the first time compared with alloy steel, that it actually had a smaller life than the alloy steel because you did not make it properly.
Yes, exactly. Yes,
right?
this is
so
very
also
important.
the current the current process that you use is very important.
It's very important.
Right.
Yes.
So okay, SOP.
We fine-tuned it in years.
Okay.
I could have done it better, maybe. I
How
don't know.
much can they pay you to leak this out in the public? Just joking.
Do we have cut option?
Yeah, we can cut this out.
Okay, never mind. So we were talking about SOP, right? Okay, so firstly we make I won't go into very deep details, but broader SOP, right? Okay, so we cast a grade, we make a recipe first. This recipe has a combination of alloying of copper, moly, and nickel. So these are, those chemical X of Powerpuff Girls.
Okay.
Yeah, that one.
So this is while you're making the ductile iron.
Yes,
right?
while you're making
melting.
ductile
So
iron.
does ductile iron also have these three?
Yes, in the harder grades,
Okay.
yes. Copper is very common.
Right.
Moly and nickel are not so common.
Okay.
Following that.
So you have to have these three to make ADI.
Like proper ductile iron grade. Then the solidification time is very important. The pouring, the inoculation, your magnesium treatment, everything is important. You have to follow the right SOP for making good ductile iron. Then you make your casting, you finally send it for heat treatment. And in the heat treatment, first is the austenization process. Austenization process, okay. Yes. This is a planned heat treatment, which is tentatively done around 850 degrees to 900 degrees Celsius.
Okay.
Roughly about 1-2 hours. And
you said something about salt bath.
Yes, exactly. I'm coming to that.
Okay.
So that's a second heat treatment process.
Okay.
It's not necessary that you have to do it in a salt bath, but it's often done in a salt bath furnace. That is the austempering process.
Okay.
So in the austempering process, we cool it down, and in temperature ranges somewhere about 250 degrees to can go up to 380.
Okay. So it's mainly refining the grain structure, I would say, right?
Yes. Now that you choose your temperatures depending on the grade you want.
Oh, okay.
Yes.
Okay.
So higher the temperature, lower the grade.
So basically, just to summarize what you said, you get 900 by 9, right?
Yes.
Is your grades.
Yes.
So depending on what tensile strength to elongation ratio I want, that sort of heat treatment process is what I have to follow.
Yes, exactly.
Right,
you plan it. Then after your stamping process, you get a microstructure which has 90% phosphorite.
Okay.
So this is the heart of ADI, the microstructure. You're getting 90% phosphorite.
Okay.
There is benetic structure, about 10% in it.
Right.
And your carbide should be lesser than 1%. Martensite should be around 3% or lesser than 3%.
Okay.
And there is one carbidic ADI as well, carbidic ADI. So we intentionally put carbides in ADI, which I have not developed, but I might be studying it for future.
Okay.
And that is for even further wear resistant products.
Okay.
Somewhere in mining industry and this construction industry.
You sound like you're very focused into the mining industry. Is that true?
Not really. Like I'm personally very focused in mining industry, but it has ADI has a lot of application there.
In the mining industry?
Yeah, it has application in a lot of industries, like seeing the properties, what we are talking about.
Right.
But in specifically like ground engaging tools, where you are using those tools to move sand, rocks, and cut those, break those. There's continuous wear is happening.
Right.
You need strength. So
correct.
That's how ADI comes into picture.
Correct. Now I want to ask you. You said castability is on par with ductile iron, because essentially you are pouring ductile iron itself, right? So there's no change in the ductile iron process. You add your magnesium, your treatment,
everything.
all that remains exactly as it is.
Yes.
Okay. Let's go on to the cost part of it, because people must be wondering how much does this ADI cost? You're comparing it to alloy steel, right?
Yes, exactly.
So, like, compare the cost for me.
Yes, it is, as I said earlier, ADI often comes at a lower cost than high alloyed steels.
Even with the heat treatment, the energy needed for all that? Okay.
Everything. Okay. I'll tell you why. Very simple. A layman can understand. If suppose the properties are similar, and this, like for a moment, you are assuming the properties are, the strength properties you're getting are similar, ADI is 10% lighter than steel.
So it's a density to density comparison.
Yeah, exactly. Okay. Density of ductile iron versus density of steel.
Okay.
So it is lighter. Lesser per kg product.
Got it.
It's as simple as that.
So that is why you can offset the energy cost for the hardening and everything else.
Because in steels also, you somewhere where this kind of application is required, you harden it.
Right.
So I'll tell you, you take some examples of the route I'm talking about, route of production.
Right.
So there is forging, machining, and case hardening.
Right.
That is one route. Then there is steel casting and machining and hardening. Then there is fabrication and machined with weldments,
right?
Versus ADI. So this is cheaper. I won't come into like how much cheaper, but yes, it is cheaper. Well, papers say it is 30 to 40% cheaper.
So are your customers buying it over alloy steel?
Come again, sorry?
Your customers are basically actively choosing ADI over alloy steel, right?
Yes.
Then that essentially means it's cheaper, ideally.
I'll go back to 2019.
Okay.
So there was this product. It's a towing product. My customer in America was buying it from China, and he was buying it in IC, investment casting steel. And so it created a lot of value for him when we did this trial. It was an opportunity for us as well, because it was the first product I got that was in grade 1 ADI. And so we casted it in green sand molding and we austempered it. We gave the product to him. And I couldn't get numbers from him, but I can easily say it was more than half the cost. Like more reductions than half the cost.
He was a happy guy.
Very, very happy. And we are still doing it.
Right.
2019 till 2024, sending.
That's good.
Yeah, every month.
That's good. That answers our question, whether it's about the cost factor.
Yes.
So that's great. I want to ask you now, you've given us the cost, you've given us the properties, you've compared it with alloy steel effectively. What are some applications industry-wise? Like you've already mentioned mining.
Yes.
But are there any other industry applications? Like you're producing it right now, right?
Certainly.
So just tell us about practicality. Like
Sure. So first what I've already told, let's summarize like why we're using ADI. So ADI basically has higher tensile strength and toughness, and it has work hardenability,
right? And
it has good castability,
right?
And it has good machinability,
right?
Basically, the lower grades, they have good machinability,
right?
And because I'll just go deeper into machinability again now.
Right.
So in the basic 3 grades, the grade 1, 2, 3 of ADI, you can just austemper it and machine it. It's not a problem. And in those grade 4 and 5, you can machine it and austemper it. Okay. That's one route of doing it.
So you're saying the austempering is after the machining?
It's both ways. That's what I'm saying.
Oh, okay.
Yeah, in the softer grades, relatively softer grades of ADI, what we used to do in grade 1 was, we used to machine it.
Say you do the heat treatment after the machining, does it maintain its dimensions?
There is a difference, 0.2%.
Okay.
So I'll take a specific case of chain sprockets.
Okay.
So these chain sprockets, they are massively getting manufactured through the ADI process.
Okay.
Massively.
There you have an application already.
Certainly.
That's good.
So these sprockets are machined after austempering.
Okay.
So they are taking the picture, the volume expansion of 0.2%, which is happening into the austempering process as well.
Right.
But these grade 1, grade 2, these products, you can machine it after austempering.
Okay.
Yes, you can.
So any other applications of
We'll come into applications. Yeah, we just keep getting lost. Okay. So I was talking about the properties, why it has to be used and where it has to be used. So coming into the industries where we're using it, first is automobiles, agriculture, railways, mining, construction, everywhere. Talking about some products of automobile, camshafts, gears.
So these are what you are actively making right now in ADI?
Not all. I'm not making all of these, but I'll tell you what I'm making as well.
Right.
But these are actively being produced by people all over the globe.
Okay.
In ADI.
Okay.
ADI was discovered about 60 years ago, and it was in 1972 that it got its commercial application, and since then it is getting used in these all industries, actively getting used. In India, it's rising.
Right.
I will say it's rising.
Right.
People are asking about it. OEMs are asking about it, and
so it's not widely adopted yet.
I think so. Maybe I'm wrong.
Right. If you guys, anybody else is producing ADI, please comment down. We'd like to know you, right? Maybe you have a competitor. Who knows? That would be nice. Because I'll tell you a funny story. Like 10 years back, when I started my career in the industry, I was hearing SG iron, ductile iron, nodular graphite iron, and it was very complicated. Like, what are all these grades? Then somebody sat me down and said, they're all the same thing, right? So that was a reality check. But I mean, ductile iron was pretty nascent at that time. Not a lot of people were making it 10 years ago. It was the magnesium, maybe the treating.
Correct you there, but no. Ductile iron was pretty much popular, pretty much widespread 10 years ago. But if you go back like 30, 40 years ago in India, yes.
Then maybe it was.
Yes,
so 10 years ago, but this is what I felt, because I spoke to a lot of foundries and they were making, cast iron and grades of cast iron.
You're right. Grey cast iron is easier.
Yeah.
A lot of people are making
probably it. Probably the hazard of, alloying it with the magnesium, the ladle, the treating, that is very complicated.
You're right. You see, earlier when, go back, generations back, there were cupola furnaces.
Right.
So that's why they were making grey cast iron.
Correct.
So now they have induction furnaces.
So it's easier
to control the temperatures, alloy and everything.
Yeah. So back to
applications exactly.
Right.
Yeah. So camshafts, gears, these sprockets, and differential spiders, rotors, differential cases.
So almost like everything, and these are more automotive.
These are mostly automotive applications I'm talking about. Coming to railways now,
right?
Then there are reducers, retarders, brake shoes. I'll tell you, I read somewhere in Europe they are actively making rail wheels.
Oh, okay.
Yeah, in ADI, which was steel earlier.
Right.
And I'll tell you again, these are low-speed railways. One they are making, and there are some high-speed railways as well, high-speed wheels. They are not making ADI for high-speed rails because I read somewhere that where the application is more than 300 degrees Celsius for a longer period of time, then it is not advisable.
Okay.
So in low-speed wheels, and then there is braking beams,
That's something very powerful you said, where the application is more than 300 degrees. Right,
for a longer
extended
duration
period of time, you do not choose ADI.
Yes, exactly.
Okay, so that's a few pointers for you guys.
I read somewhere. And this special article I read about brake beams in Europe, which they have converted to ADI, which are, I think, 20% lighter.
Okay.
Yeah, not just because the 10% density part, they designed it 20% lighter than steel. And Europe is actively making those for railways.
Right.
And me personally, I'm also making some products for railways. I'm making some backing rings and end caps, which are assembled in a CTRB, which is a taper roller bearing assembly.
Okay.
And I'm exporting it to somewhere, to some customer.
Okay.
Yeah. And then apart from railways, it's used in agriculture because there you need some ground engaging tools in agriculture as well.
Just to round up, if you had to summarize maybe ADI applications, and you have to pick one industry, like whether it's automotive, railways, agriculture, pick one. Where is the largest market for ADI right now?
See, capacity of buying, that's with automotive.
Okay.
Trucks.
So automotive is
trucks,
what you...
Castings.
Because you also mentioned that you're making some for Jeep, for Fiat Chrysler.
Yes. Right? I'm making a towing hook. And
in ADI, right?
Yeah, in ADI, of course.
Right. So automotive is a good application for
heavy volume.
For this.
So it's that hook kind of thing which is right in the front bumper to pull the vehicle.
Right. So if you have a Jeep Rubicon, the likelihood that Preet made your castings is very high. So let's move on to you mentioned about prototyping.
Yes, exactly.
Right. You said that prototyping is something that ADI uses it.
It's a better choice. It's an easier choice. It's a more feasible choice. Why?
Right.
Because when you design a component and you give it to some forging guy, and they'll ask for the volumes and dies and everything, and it's so easy in ADI. You get a 3D printer, get it hand molded, and get a casting the next day. Next day you Austemper it, and on the fourth day you have a product ready.
So this is comparing with steel forgings.
Yeah, I'm comparing with steel forging now, and otherwise I'm talking about rapid prototyping. It's one important aspect why we should be going into ADI, why we should be developing ADI right now. The same with ductile iron also.
Right.
Ductile iron also has this feasibility of rapid prototyping. But when you have a material of choice, which demands higher strength, higher properties, then go for ADI.
Right. So that's another use case. Maybe it opens up another job market for a prototyping sort of setup.
Certainly.
With 3D printing also.
Yes.
Right. That's good.
I want to mention, I got a call from Heroes R&D about 2-3 years ago. They wanted to test kicks, bike kick in ADI. I eventually quoted them, but it didn't go through. Into process, but they were doing it. Maybe they're doing it now. I don't know, but people are making kicks in ADI. Nice. It's fascinating for me.
That's good. So we've covered a lot of applications. We've got properties, right? Now I wanted to go a little bit. You also mentioned that your carbon emissions.
Yes.
That's something that's a lot of European manufacturers are talking about.
Now the question comes, why a foundry man should learn about ADI, right? So one of the most important aspect of this question would be, it's greener, I would say. In simple words, it's greener. It's a greener choice
than alloy steel.
Right. Yes, it's a greener choice than alloy steel, because I read somewhere about greenhouse gases, like how much tons of CO2 is emitted while producing a product. If you choose it, say a brake rotor, if you choose it to make from ADI, or you choose it to make through maybe forging steel, you machine it, you case harden it. So first of all, lesser emissions, lesser energy consumed, and lesser material used.
Right.
And it is the ductile iron. It is gone through a recycled route. You're recycling the scrap and melting it.
Right.
So it's made through a recycled route. So it's a greener choice. These days, I actually met a customer a few months ago. He's an Italian guy. He told me that in near future, your European customers are going to ask you to count your carbon credits. They want to buy from foundries who are reducing carbon credits.
So you mean foundries will be graded by their carbon credit, right?
Maybe. I was a bit astonished, I would say.
I can see a new market for that. I can see an entire market of subcontractors, called by European customers, hey, go and grade these people on their carbon credits, right?
Yes, you are right.
That's probably a market that's a good market to start a business in.
Yes. Auditors?
Yeah, auditors.
Yeah,
right.
Greenhouse
greenhouse
auditors?
I do know a few. Right.
I don't know.
No, they actually install a lot of devices at your place. Pollution is something that the government tracks. But if a third-party organization would do this for your customer, the chances that you would take this seriously are much higher.
Yeah,
because the customer ultimately is going to approve your castings or disprove them.
Yes, so business is important.
Right.
Yeah, you need to go into sustainability. You have to choose sustainable options.
Right.
I actually learned from your podcast about sleeves which are greener, which is a green choice.
I got to tell you this, guys. Joy Feedtech was on episode, I think 12 or 13, I believe, Leo Christopher.
Yeah.
So immediately after that, I get a call from Leo 3-4 days later, and he's like, a certain person called me, watched the podcast, and has ordered his first batch of sleeves.
And it came today.
And it just reached.
Yeah.
That's good. Congratulations.
Back in my foundry.
Right.
Yeah. But I want to specifically mention the
eco-friendly.
point. Yes.
Eco-friendly.
Yes.
Right.
Apart from imparting those, special feeding properties to my ductile iron, I would say green choice.
Right. So thank you, Leo.
Thanks to you.
Yeah. No, thanks to Leo actually. Leo's the guy who
for the platform, I would say.
Yeah. Anyway, thank you so much for being. Anyway, why don't we get on with it? So that covers carbon credits.
Yeah.
Right. It's lower.
Yes.
You also
lower emissions.
You also mentioned the importance of us tracking our carbon credits, right? Which is something that we've spoken about. Let's go ahead. You also told me about something that I don't know if I can talk about, but there is SSF, right? Yes. So what is SSF?
Yeah, we were talking about what next,
right? What next after ADI? You're going so ahead in the future right now.
See, I am in touch with a professor from Sweden, from Umeå.
It's always scientists who come up with these things, right? Wearing lab coats. This is how I picture it. Like somebody in a lab trying something with ADI, try SSF, as you mentioned.
I don't know how it is, but so I was writing on LinkedIn about ADI. So he approached me, and he also works as a CTO in some Austempered company.
Right.
So I usually interact with him for ADI questions. And he has written a paper on SSF, which is solution strengthened ferritic ductile iron.
Solution strengthened ferritic ductile iron. Okay,
yes,
I
exactly.
got to write this down.
SSF, ductile iron.
Okay.
So basically what you do over there is you increase your silicon percentages to up to 3.7, 3.8%. You reduce your carbons, you maintain your CE so that you do not go into a hyper-eutectic composition.
Okay.
So what's the result? You get a fully ferritic grade of ductile iron, say 500 megapascals of strength with 14% of elongation. So it is not just the elongation we are targeting with this
Correct.
SSF.
Correct.
What we are targeting is, see, when you're casting ductile iron, you get variation in hardness from first box to last box. There is variation of hardness from different areas in the casting itself.
Okay.
We want to narrow it down. We want to make a grade which has very narrow range of hardness difference amongst these products. And think of a product like a disc rotor, which has very tight tolerance of dimensions, and we want a very machinable grade of ductile iron where your tooling consumption goes down maybe by 30%, 40%, and your rejections in machining go down to absolute zero because of material. I mean, not because of machining, but because of material.
Right.
So this is what I am thinking, what I am learning, what I am going to develop soon, and maybe I come back to you soon.
Yeah, maybe you can come back and talk about SSF.
SSF.
So right off, just to summarize, what is it? What is its aim? What is it trying to do? What are you trying to achieve with SSF? Like in a nutshell.
In a nutshell, make a casting which is highly machinable.
Highly machinable.
Highly machinable. And yes, it will have more elongation.
Okay.
More elongation. The properties are increased. Your cost of production is not increased much. I would say maybe 1 or 2% because just increasing your silicon. That's it.
Correct.
And you get to a product where your tooling consumption goes down heavily.
Okay.
Your machining tooling consumption goes down heavily.
Correct.
And lesser rejections. Why not?
Great. So we are going to expand on this in the future.
Yeah.
That's nice. Anything else you'd like to add, Preet?
Can I ask you a question?
Yeah. Sure.
Okay. So, where do you see yourself, your Foundry podcast after a year?
This is not in the script.
Why not?
I don't really know. We started this just for fun, to be honest, like right here, just for fun. I'm not really sure where exactly it's going. But it has started to pick up. Like you reached out to me. A lot of people from across the nation are reaching out to me. We've had international guests now.
Okay.
So it's going a little bit international. We'll have more international guests coming soon.
Mm-hmm.
So it's really going into something that I don't know which turn it could take. So we are expanding a lot. We are adding a few products to the pipeline so that we can expand the reach. Like for example, the Foundry Shop. I was just showing you the Foundry Shop a little while earlier. So that's something we are planning to launch, I think probably the week that this episode releases. So the Foundry Shop is aimed at being an extension of the podcast. We already have, we're covering a lot of journeys with the suppliers. We are talking a lot about new innovations, things in the industry. So to help Foundry people as well as suppliers have a better reach, we're starting a website where we're going to be cataloging every single person's equipment, like equipment for sale, filters, sleeves, like you both bought. So everything on one website.
Like a marketplace.
It's essentially going to be one place where you can see everything for the foundry industry, all available. Like new technologies, we want to cover all that in one place. So that's essentially what the Foundry Shop is going to be like.
Actually, it's a brilliant idea. I would say it's kind of a summary of all your podcasts. There's suppliers on your podcast, and everybody's there on the website.
A very clear extension.
Yeah, it's a great idea, and I did with one product. So I can choose better products for my Foundry.
And also you get to see, like if they've done a podcast as well, you get to know the person, you get to understand the founder's vision, like learn their culture, their habits, because you can learn a lot about a company by how the founder talks about it, by their body language, right? So those sort of things are just what we're trying.
The most important word, trust. Trust builds up.
Trust, right. So that's something that, if you're buying capital equipment worth like 1 crore, like how do you do your groundwork? Where do you do research? If you're buying a car for 10 lakhs, we go and watch like 10 review videos, right? Some guy with a camera. We're buying capital equipment worth crores and multiple crores. And how do we do our research, due diligence? There's no independent authority body that can say, okay, this is good, this is not good. So while we don't have the authority to do that, what we can do is we can put everybody in a chair, we can talk to them, and we can give them a platform where the buyer can review them all in one place. So that's essentially what we're doing with our podcast and the shop.
Lovely.
Thank you for asking me that question. I'm glad I covered that up.
Great.
So we're going to launch the shop the week that your episode is.
Okay, I'm happy.
Yeah,
it's coming along with this podcast.
That's good. So does that cover is that answer enough for you?
Sorry.
Is your question covered?
Yeah, I mean more or less yes. I've
Fine.
got, but I was thinking about you telling me numbers also, subscribers, so and so, this and that.
No, actually, I don't have any idea with numbers.
Okay.
See, the numbers, as soon as you get into that habit of tracking numbers, right, you're on a zero-sum game. You can never achieve anything of a number. So our fulfillment doesn't really come from number of subscribers, number of views. It comes from, like you said that you bought CDs from Leo.
Yeah.
That's enough for me.
Yeah, you're right.
I'm good with that. Another person on the podcast said that somebody approached them and got in touch with them and they sold some machines, some really good new innovation. So they're also going to be on the podcast sooner or later.
Wow, great.
So all these new things are coming out. Anybody has something to say, this is the place to do it. And let's just see where it goes. I mean, I'll have to find some way to extend it.
Brilliant. You're adding value in our lives.
Yeah, so that's it. But there's no metric to it. I mean, I can't give you that about.
Okay, perfect.
So that's good, Preet. Preet, thank you so much. You've come all the way from Punjab here.
Thanks to you.
And I think you did connect with me a couple of months or years back.
I think, more than a year.
Right.
I wanted to buy bronze bush from you.
He contacted me to buy bronze castings, then randomly you probably clicked on my number to message me about the podcast and realized, oh, we had a prior conversation.
Yes, exactly. That's how I came to know.
That's nice. So you were at the Valve Expo.
Yes, I was here.
How did you find it? Anything that you can add to the audience?
It's good. It's a small exhibition and various Valve guys were there. I make butterfly valve bodies, so I was so networking with people.
Right.
My cherry on the top was the podcast, of course.
Okay.
Yeah, but I connected these two things in my visit.
Great. So if you guys really like Preet's episode, like and subscribe. Reach out to us. Also comment below if you guys are making ADI castings, right? Let's look for some competitors.
Yeah,
I hope your customers are not watching this.
I would say let's talk.
And let's talk. We can discuss ideas, rebound them off. Also SSF, right? If you all want to see Preet back talking about SSF castings in the future, which you are actively, I think, developing now. Also, let us know that in the comments.
Yeah, now that's a motivation. I have to, and I have to come back.
So that's very nice.
Yeah, innovation is one thing which I think I would like to add on for your viewers.
Okay.
It should go on. Okay. Innovation should go on.
Yeah.
You should keep, doing something new in your be it foundry, be it machine shop, be it any manufacturing. And I'll dedicate this to my father, who has been always pushing me for innovation, innovating, reading, learning. It was that time in 2016. He could have stopped me. What are you doing this? But there is no market for it. We are wasting resources.
Right.
Come learn what we are doing. So, but he kept the push on.
That leads me to a question I want to ask you. How much of your production right now is ADI based right now?
It's very less at the moment, but it's significant. We are doing, it's picking up. It's still significant. We are doing about 25 tons per month, and overall we're doing 300 tons of casting per month.
So that's about what, 8%?
Yeah, roughly. You're good with maths.
So that is a sizable chunk. And also, if you're looking at cast iron in the future, right, and you find the relevancy of cast iron going down due to aluminium and things like that, like adding ADI to a portfolio, is a little bit of a insurance policy, I would say.
Yes, it's an insurance policy. It gives you an edge, and I'll also add it gives you a marketing point. When you're online, your customer is searching for ADI, and your company pops up. So he doesn't buy just ADI from you. There's a whole bunch of castings.
It's likely that he will be buying cast iron as well.
Already making.
Right. Exactly. That's a good, really good point.
I actually got a lot of customers which are buying now ADI plus grey cast iron from me because they searched me from ADI.
Correct. That's great. So you come across like a market leader with ADI, and it's natural that
because lesser competition in India at the moment.
Right.
But you never know.
Right.
What happens in the future.
That's good. So that's good, Preet. Thank you so much. Lovely having you.
Thank you.
And we'll see you guys in the next episode. This is episode 15, right? And keep watching. Thank you.
Okay, bye bye.
Thank you.